All right, guys, so welcome back to week 10, class number 2. Yesterday, I showed you this reaction, the oxidative cleavage of alkenes, cleavage by potassium permanganate. Now, in order for this to happen, we typically, like in the chemistry lab, we added an acid or a base to help this along. Typically, to help this reaction happen, you would make it be warm and have concentrated solution. And in the lab, we actually added an acid to kind of act as a catalyst and help this reaction along. But really, all you need to know is when you add potassium permanganate, permanganate specifically, permanganate, by the way, being the polyatomic ion, it's a oxidation reaction, excuse me, meaning that the alkene gets split, cleaved, cut in half, and then oxidized. So let me show you this bottom example, and then I'll show you an easier one that you might see on your final or a worksheet or something like that. So I'll show you this one. This one is quite difficult, and then I'll show you an easier one. Now, let me just do something. I got an idea because, oops, every time I make a blank slide and I like kind of go backwards or forwards, I lose my progress. So I got an idea here. All right, so let's look at this bottom example. Okay, so for this bottom example, we have a not an aromatic, sorry, a cycloalkene, cyclohexane, or cyclohexene, I guess I should say. Oops. And it looks like this. Now, this one, by the way, guys, this is a lot more challenging or a lot more difficult than you would see on like a test, for example. So what we need to do here is every single double bond, we cleave, we split, and we add an oxygen to the end of that. Now, this one can be challenging. So let's pick another color. Let's go with blue. I'm going to split this double bond, and I'm going to split this double bond. Okay, so again, this one is a lot harder than you would probably see on your final exam. So let me redraw this molecule. So I get this and this with a double bond. But now, because I've split this double bond, I put an O here, and it splits. Actually, let me write that a little lower. And I get a double bond O here. All right, now I'm not done with this guy on the bottom yet. All right, what about my cyclohexene ring? Well, this also gets split. Sorry, there's a hair on my monitor. Okay, and we put an O on the end of each of these. Let me make that a little more. I guess I could just draw it down. I'll do it like that. So you'll notice that wherever I saw a double bond, I cut the double bond in half and I added an O to that double bond. Now, what you do, the last step for this problem is count every carbon that count every carbon that has a double bond to the oxygen. Oops. So actually, here, let me pick a different color. Well, no, I won't pick a different color. I'll highlight it. So do you see the yellow highlighted there? That's every carbon now that has a double bond oxygen to it. Now remember, The potassium permanganate will keep oxidizing these double bonds until I have 4 bonds on my carbon. So over here on the left carbon, top left one, this one here, I have 1, 2, 3, 4 bonds. He's good. Check mark. No problem there. Okay, going to the right carbons, the two carbons on the right, I have 1, 2, 3 bonds. So I need to add another oxygen to that. So I add an OH. And here I need to add another oxygen to that. So I add an OH. So now everything has 4 bonds coming from it. Now this one on the bottom only has 1, 2 bonds. So here I add 2 bonds. And when you see this in your notes, let me pick a different color. In your notes, they call this CO2, carbon dioxide. This is, again, about as hard as these would possibly be. Okay, so just kind of picture this and come back here. I have the same elements. I have the double bond O, I have COOH, which is a carboxylic acid, and I have CO2. Now, this one, like I said, is quite hard. Let me show you one that would be more, wink, wink. Well, actually, how about this? I'll show you one that will be more like what you would see on an assignment or final exam, but I'll give you guys a minute to just see if you can do it. Now, again, this is not easy. So I'll keep this. Let me just make another blank slide. Sorry, I'll share my screen in a second. I'm just going to make another blank slide here. And what I'll get is just to see if you guys can try this one. This would be more like you would see, like I said, on a final exam. So, all right, let me fix that double bond in my methyl group. I'm a perfectionist, I guess. There we go. So try this one. And we're reacting it with, again, the potassium permanganate. All right, so I'm going to mute myself for 2 minutes. This is hard, and if you don't know what to do, that's fine. I will show you what to do in a minute. But just try this one, and I'll be back in 2 minutes. All right, so let's have a look at this answer here. If anybody's nervous about this, maybe nervous isn't the right word, but if anybody's confused about this, hopefully this example will make you feel a little better because it's really not as hard as it looks. I'm just going to clean this up so I have a little more room to write. Okay, so what do? We split the double bond. So I'll pick another color. I'll go with blue again. Split this double bond, literally cut this molecule in half at the double bond and write each side. So if I, like imagine I had a pair of scissors, cut it in half. So I end up getting this. Okay, that's not my best shape. There we go. That's a lot better. And I get this. And okay, so there we go. I literally cleaved or cut this reaction in half, or this molecule in half. And now what I do is I put an oxygen on either side of the double bond where I cut it in half. Okay, so I'm almost there. So if you did this on a test, you would almost have full marks right now. There's only one thing left to do. On each carbon, count the number of bonds. So this carbon and this carbon, the two I've highlighted in yellow there on the right. Okay, so let's count. I'm counting on the left. Let me pick a different color too. We'll go with green. So 1, 2, 3, 4. That carbon on the left has 4 bonds. It cannot take any more oxygen. The carbon on the right, however, has 1, 2, 3 bonds. So I can add one more bond to that. So I add an OH. And there we go. That's your two products. That would be the oxidative cleavage of this compound. This would be what? 2 methyl, 1, 2, 3, 4, 5, 2 methyl 2 methyl 2 pentene. Excuse me. And now it's not. Now we've split it into an aldehyde and a carboxylic acid. All right, so that's it for that. So these examples are here. And that's really it for chapter 3. I'm not going to do the rest of chapter 3. But we can do slide 71. Okay, let's do slide 71 for practice. So you don't need to worry about 69 or 70. Okay, so you can skip those slides, 69 and 70. But why don't we try these? All right, so I'll mute myself for a minute and try these. By the way, B here, it's because of the computer program I used when I made these notes. B would look like this. Okay, so there's B. So why don't you guys try these two? I'll be back in a couple minutes, and then we'll move into chapter 4, and that's it for today. All right, so I'll give you guys another couple minutes to try these two. It's really important that you try these because you will see one of these types of questions on your final exam. So just take yourself, I don't know, 2 or 3 minutes to try these, and then I'll be back with the answers, and we'll very quickly move into chapter 4. So yeah, I'll be back in 2 minutes. All right, let's have a look at your answers here. Again, something like A would be very, fair for your final exam, for example. Even I guess something like B isn't too bad. So I'm just going to write this down on a piece of paper so I can go to a new slide here. And let's B. B looks complicated because it's a big molecule, but it's really no different than the other ones we've been doing. All right, so let me open up a new slide here. I'm going to kind of clear my screen again. Just be back in 1 second with a new screen. All right. Okay, let's have a look at this. So the first question was 3-methyl-2-hexene. So 3-methyl-2-hexene. Okay, so first thing I need to do is I need to actually draw this. So 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. On the second carbon, I will put a hexene. On the third, I'll put a methyl. We've actually already done one like this. I mean, once you see one, it kind of gets repetitive. So what I'll do is I'll add my KMNO4 here. I'll split this double bond in half, like that. So I'm like cutting it in half, and I end up getting this molecule, and then I get this molecule. Oops. Okay, so now what I need to do is I need to look at the carbon of each double bond and count and see how much room I have left for this, for another oxygen, for example. So on the left, I have, let's just pick a new color. On the left, I have 1, 2, 3 carbons. On the right, I have 1, 2, 3, 4. So that means the left one, I can only add 1 oxygen to it. And the right one, I can't add anything. So there we go. There's my new molecule. All right, what about B? Well, it's the same thing. Exactly the same thing. The only difference with B is you have a bigger molecule, but it doesn't mean it's any harder. Okay, so again, I'll add KMNO4. I split my double bond. So cut that in half. That means I end up with this compound and this compound. All right, stick oxygens at the end of those double bonds. And then count how many bonds you have on each carbon. So here I have 1, 2, 3. Here I have 1, 2, 3, 4. So that means on the one with 3, I can fit another oxygen in there. Phew, there we go. That's it. That's it for chapter 3, guys. We don't have to do any more of the slides. So that is it for chapter 3. All right, okay, so what I'm going to do now is open up chapter 4 and just introduce it. I won't do too much of chapter 4 today because it's already 10 o'clock, but I will introduce chapter 4. And yeah, that'll be it for today. Just give me maybe like 5 minutes or so. So guys, chapter 4, so that's it for chapter 3. Chapter 4 is only 23 slides. It's by far the shortest chapter. All you need to worry about for Unit 4 is basically how to name some aromatic compounds, which we'll talk about tomorrow. We'll finish this. We're going to finish Unit 4 tomorrow. Okay, it's really short. It's like I said, it's only 23 slides. So the only thing that you really truly need to know from chapter 4 is what we're going to do tomorrow. It's the structure, or sorry, not structure, the naming of aromatic compounds. And it's really easy. Now remember, nomenclature means naming. Okay, so let me just give me 5 minutes to kind of introduce section 4.1, and that will be it. So section 4.1 is the structure of aromatic compounds, and we did a little bit of this in Unit 1. In organic chemistry, aromatic compounds are usually cyclic rings. They're flat. They have a resonance structure that give it stability. Now, what do I mean by resonance? Resonance, and we're not going to get too much into this in this course, but if you were doing an organic chemistry course in a university, you would study resonance a little more deeply. But resonance is the idea that these double bonds in the ring, I'm drawing down here in the ring, they can move. They can move around the ring. There we go. And you can notice that these structures, they look the same, but they're not the same in terms of the double bonds. So again, let me draw my little arrows again. Like imagine, so I'm over here on the left. imagine if this double bond moves here, this double bond then is crowded, so he moves here, this double bond moves here, well, then we would get this structure. And then this structure could do the same thing, move here, move here, move here, and we would get this structure. So this movement of the double bonds, they call resonance, and this provides stability compared to other arrangements of similar sets of atoms. So like similar to like other rings or straight chain hydrocarbons, aromatics are very stable. So I would know that aromatic compounds are the aromatic ring is very stable. Stable means typically not reactive. When something is stable, it's happy, it resists change, so it's usually not reactive. So alkanes, for example, are slightly more stable than alkenes and alkynes in terms of reactivity. Alkenes and alkynes are much more open to addition reactions, for example. Aromatic compounds, even though they have double bonds, the layout of those double bonds makes them a little less reactive than you would think. They're stable, they're happy. So aromatic compounds are very stable. They do not break apart easily. They do not react with other substances very easily. It can definitely happen, but it's not as easy as, say, an alkene. You don't really need to know this one here, but we did this in Unit 1. Or maybe Unit 2. I don't know if it's 1 or 2. It really doesn't matter. But if they're not aromatic, we call them aliphatic. And they could be cyclic, right? So like this is not aromatic, okay? This is cyclohexene. It's not aromatic. Aromatic has to look like this. And sometimes people draw aromatic, instead of drawing all the lines, they put a ring in the middle. The ring represents the resonance, meaning that the double bonds move around inside that ring. So these are aromatic on the right. Okay, let me just see. Well, I mean, honestly, I think that's really good for today, because there's no point in getting into this section. This is the big important section, and we'll do this tomorrow, and we'll kind of finish off this chapter tomorrow. It's a very, very short chapter. We only have about 18 slides left, and they're very quick. So let's kind of call it here for today. And if you guys have any questions, let me know. If there are no questions, you guys have a great morning. And make sure you wear your mask and wash your hands. All right, so I'll see everybody tomorrow. And if you do have any questions, let me know.